Hey everybody, welcome back to RC with Adam. My name is Adam and welcome to the second part of the 4-part beginner 3D printer series. I'm going to walk you through the entire process of designing this motor mount. Right now we're in the second video and we have sketched our design, and now we're moving into TinkerCAD to actually model our design, and then after this video we will bring it into Cura to slice it. So let's go. Boom, here we are in TinkerCAD. So we're going to jump on in here. If you don't already have an account for TinkerCAD, you can just go to, I think it's tinkercad.com, and you can get a free account so you can start designing stuff. So I'm going to click create new design. And here it's going to give us our work plane right there. It even says work plane. So let's just do a little tour through here just in case this is brand new to you. And feel free to fast forward if you already know this stuff, or check the little timestamps so that you can skip around. But what we're going to do is I'm just going to take you through this really fast. So up at the up at the upper left-hand corner, we have the name of our item, which we can change that. It just gives us a random name. We have some options here like to copy, to paste, to duplicate the items and delete the items. And we have our undo and redo buttons. Also, you can navigate around the workspace using this little three-dimensional box thing right here. And here we have some different like viewing options for viewing. What you can also do is just right click and hold, and that will rotate you around the work plane. Or you can, in my case, I have a little scroll wheel on my mouse. And so I can actually click that down, press down on the scroll wheel and move like left and right around the work plane. And by the way, I am on a Mac, but the controls should be mostly the same if you're on a PC. You can also do shift and right click and hold it down to do that sort of left and right movement as well. But for me, it brings up the right click menu, so I just don't use that. On the right-hand corner, or the right-hand side up at the top, we have import, export, and send to options. We have the option to create a work plane, which we don't need to do right now because we have this one. We do have a ruler option, which we will use in just a moment. And then we have basic shapes. So on the right-hand scroll bar, we have all these different shapes. And the way TinkerCAD works pretty much is like they give you all these different shapes, and you can combine them or cut them out with other shapes to create new shapes. So it's very basic in that sense. And you also have some other options, like you can actually make like different connectors that they give you, so some different shapes that you can work with, which is pretty cool. But right now we're just going to use the basic shapes, and these shapes at the top, these particular ones, these are grayed out because they are actually like they will make a hole when you combine them with other shapes. Speaking of combining them with other shapes, up at the right hand corner here we have some options to combine the different shapes, which we'll use in just a moment as well. So that's pretty much it. And then you can use your left click and hold to select different items, and of course for like general selecting stuff. So first thing we want to do is we want to grab our ruler. So we will grab our ruler, drag it, and put it really anywhere. You can pick it up and put it anywhere on the work plane. And the work plane, think of that, you could think of that like our tabletop. That's our work area. Oh, also the scroll wheel is for zooming. So if you have a scroll wheel on your mouse, that's going to be for zooming. Otherwise, you can zoom on the little buttons on the left-hand side. So that's how you can kind of move around and navigate in this space. So the actual ruler is important because that's going to really help us to place things properly for dimensions. It doesn't matter where on the work plane you put it. Usually at the center is where you might want to put it. But what really matters is that we have the ruler, and then you can see we have you could think of it like the y-axis and the x-axis, but basically we have two different axes on this ruler, and that's going to really help us a lot to get all the dimensions correct. So we have that there. That's great. Now what we'll do is we'll actually start out building the front of the motor mount, so where the motor will actually attach to. And to do that, we're going to grab a box shape right here. So just a box shape. You can see it's a three-dimensional shape. And here let me actually move it like right over here. So just to show you around with this, you see in the right hand corner here we have some options. We can make this a solid shape, which is what it is right now, or we can make it a hole shape. So this grayed out shape will actually cut into another shape when we combine it with another shape. So if you want to make a hole in something, that's really great, which is what we will be doing in just a second. But for now, let's leave it solid, and you can also do some other things. You can change like the radius of the edges. You can change the steps of, well, I guess it'd be of the radius of the edges, but we'll leave it just square is just fine for now. You can also change the length and width and stuff. That's one way of doing it on that little menu right there. And so you'll see, speaking of the dimensions of this, you'll see these arrows right here, and they're highlighted in blue. And so we have 3 arrows for the 3 dimensions. So we have this longer one right here, and that's telling us that it's 28.82 millimeters. Right now, everything is dimensioned in millimeters. And what we can do to change that, change the dimensions, is we can grab like one of the corners, and we can actually move the shape around like this, kind of like freehand. Or we can actually grab these white rectangles, or these white squares, I guess, and actually just move one dimension of the shape like that. Or if it was on the side like that, we could grab it in the middle. So that's how you can change the dimension there. The other way you can do it, which is more precise, is to actually type in a specific amount. So maybe you want like, 23.5, and then you can type that in right there in those little boxes. So that's usually what you do if you want a specific dimension. Also, as far as actually moving the shape around, you can grab these black, I guess they're like cones. So for moving the shape up and down, so on the vertical dimension, you want to grab that black cone or triangle right there, and that's how you can move it up and down. You can also rotate the object using these little rotational arrows, and it'll give you like a little compass dial thing. And if you pull out, if you go farther outside to the outside of the little degree measurements, you can be more precise. And if you go on the inside, it will give you big chunks as you move it. So it'll give you chunks of like 30 degrees, or 22.5 degrees is what it'll do. And so you can do 45 degrees. Okay, we're almost done talking about the dimensions and stuff, but one more really, really important thing is you'll see these shaded, or these highlighted green arrows right here. So you have 2 for each axis, or axis, and then you have another one usually off to the side over here, and that's for your vertical axis right there. So that tells you how high up your object is from our work plane. And then these other 2 that are close to the center of our rulers here, this tells you how far that object is from the center. Now, this is a really important point right here. This little circle with the lines through it, you'll see it says use midpoint. That's giving us the option to use the center of this of the shapes. So instead of so like for example, when I change this, you see these shaded green arrows. They go all the way to the middle of this rectangle. And if I click on the little circle with the lines through it, and I say use endpoint, they will get shorter, because they're measuring to this endpoint of the basically the corner of the rectangle. Also, another thing that might catch you by surprise is this guy right here that tells us the vertical distance of this object from our work plane. If we go back to using midpoint, then it will tell us how far the middle of that object is from the work plane. So that could be confusing if you're trying to get everything at the same height. So keep that in mind, that that's going to always be half of the actual object. Or half of the object plus the distance that it actually is off of the work plane. So anyway, just keep that in mind, but we shouldn't run into too many of those problems. If you enjoy these videos, you can become an RC with Adam supporter over at ko-fi.com/RCwithAdam. That's Ko-fi.com. What is Ko-fi? Well, it's like Patreon, and you can donate and support your favorite channel, but it's better than Patreon because it's not Patreon. Thank you so much, and let's keep going. Okay, I know we kind of blasted through that, so if you have any questions or comments about that, leave that in the description below. Also check, or leave it in the comments section below, but also check the description below this video for other great tutorials on TinkerCAD, and I can make some more if you guys are interested. So we're going to start with this basic shape here. Again, we're using the midpoint of the shape, and let's make sure that that shape is actually touching the actual work surface. So I can actually drag this down a little bit and it is flush there, and you see it snapped into place, and that's because if you look at the bottom, I think you can see it in the screen, the bottom right of the screen, where it says snap grid, it tells you how precise you want the snap level to be. So you could say 0.5 millimeter or 0.25 millimeter. I think we'll need 0.25 millimeter probably. I like to keep it pretty precise. And so that allows you to be more precise about how you position your object. So now that we have that taken care of, what we can do is we can center this square, or this rectangle shape, right in the middle of our workspace. And so to do that, we can take these two highlighted arrows and make them 0. I'm going to enter 0 into those little boxes, and you'll see it snaps it on both axes to the very center of our ruler, and that's very useful. So now we can dimension the box, and as we wrote out, we want this to be, because again, this is we're gonna actually work on this and then rotate it and flip it upward, or we really don't even need to do that necessarily, but anyway, so this is the part where the motor actually attaches to. So this is going to be 30 by 30. And again, that is millimeters. And then for the thickness, let's do, it's kind of hard to say. Let's do 3 millimeters and see how that works. Now you see here, because we have this set to the center point, this is actually, it actually sort of squished it. It changed the dimensions from both ends actually. So that's kind of annoying. So an easy fix for this whole thing floating in the air to get it back onto the level surface is we can change our little reference point, I guess, to say use endpoint, and then we can just go over here. Where'd it go? Oh, right, yeah, and then we can just go over here, and this is telling us that this block is 8 millimeters above the work plane, and we'll just type 0 for that, and then we can change it, our reference point back to the center. So you see those lines, they change from the center to the corner there. Okay, cool. So now our basic shape is done for the front of it. Now we need to make the holes for our motor mounting screws and the cutout for the actual motor shaft and retaining clip, because you always got to remember that, because that's one thing I always forget. So what we'll do is we'll get a cylinder in the right hand corner here. We'll just drag out a cylinder. You can see that cylinder is way too big. And the little shape menu here will say we want it to be like 64 sides, so it's nice and smooth. And then we'll change the dimensions of the cylinder to let's see. So let's for the center, let's make it 6 millimeters, a 6 millimeter diameter hole. And the height does not matter because we'll just be the height of this cutout doesn't matter because we'll just be adding it to the shape and it will sort of disappear. So here we can, again, we'll center it. So we'll, on those green shaded arrow bars and the little number box, we'll type 0. And I'm just typing that and pressing enter. And so that works well. So just to show you how this works when we have a whole object or a grayed out object, and you can see on the underside, you can see actually where the object is as well. Okay, so just to show you how it works when you combine two objects, you can either drag this little selector like over all the objects and it will select all of them, or you can click on each object and then click shift, click on an object and then click shift, and it will select both objects. And then over here in the kind of top right corner, you see it says group. So you could also do control group or control G, and we'll group it, and then shabam, look at that. We have a nice, perfect hole in the center of this square. And so that just kind of makes that shape disappear, basically. If you want to undo that, you can click ungroup, and then it will bring back the cutout shapes. Now I'll show you what you can do to copy this. You can actually, on a Mac anyway, you can hold Alt and then drag the object, and you will create a copy of it. Or what you can do is you can select the object, and then you can click duplicate and repeat, and then you just drag the object out, that duplicate object, and you can drag it wherever you want. So now what I'll do is I'll change this from, instead of 6 millimeters, we'll change this to, let's say 2.5. That should be somewhere in the right area. And we may even want to use washers anyway with this, but we'll say 2.5. Give it a little bit of margin for error there. Uh-oh. Well, that is one of the downsides of using an online editor, is that if you don't have internet, you can't edit anything. Okay, we're back. That was weird, but we are back. That happens sometimes. So now we have our 2.5 millimeter hole, and we're actually going to need like a bunch of these, so we may as well just make a bunch of duplicates. We could do that. Well, we're going to need 4 in total. So what we can do here is we said that we want the we want vertical and horizontal holes, hole spacing. All right, so let's knock out the horizontal hole motor screw holes. So what we'll do, oh, and you know what? When it restarted, the snap grid went back to 1 millimeter. So we need to actually change that back to 0.25 millimeters, so we have a lot of control over this. So what I want to do is make this, I want to make this right on this axis. So right here you can see it says -1. I want to change that to 0 on that green shaded bar. It's a little hard to see, but and then let's see, is this, wait a minute, is this midpoint? Oh, okay. So we had to change it after it restarted. We had to change it back so that it would go back to the midpoint. Okay, so let's do that then. Let's say 0. Good. So we are right in line with this center hole of the motor shaft. So then what we want to do is we want to, since the total distance, according to the measurements that we took, the total distance between the centers of the holes, and this is kind of approximate, but the total distance is 15.5 millimeters. Half of that distance is going to be 7.75 millimeters. So we want this particular, this 2.5 millimeter hole to be 7.5 millimeters from the center. So what I'll do is I will, in this this box for the green shaded arrow, I will type 7.75 and enter, and that is where the hole should be for that. So that works out really well. So we can do that, do a similar thing for this particular set of holes. We have our other 2.5 millimeter hole right there, and we want this to be centered along that axis. We could say the x-axis. So we'll type 0. So that way it's, you know, they're all in line like that. It's kind of hard to tell from that angle. Now, instead of 7.75, since it's on the other side of the axis, we actually want it to be negative 7.75. And I'll type enter, and then shabamo, look at that. It's on the other side. So that should theoretically line up just right with those holes in the motor for the screws. And we'll do a very similar thing for the top and bottom. So over here we can kind of drag it to the general area, and actually, oh, that snapped right on the axis there. So now we can say, okay, the total distance between those two was 11.5 millimeters from the center. And again, we're doing center point measurements. So from the center of the object. And we can say half of that is going to be 5.75. So we'll say positive 5.75 and then enter that in there. So now we can do pretty much the same thing with the other side, or we could sort of say the bottom. So we can make sure that this is, let's see, yep, it's negative 0.25 off. So we'll make it zeroed up on that axis. We'll call it the y-axis. And then we'll say we want this to be negative 5.75. That should work, unless my math is just totally bonkers, which, you know, is a possibility. So now we should have all the holes that we need in our motor mount. So we have a nice motor mounting pattern right there. And again, this is just one way of doing this. This is, you know, just kind of slapping this together, but hopefully it's a good example. So we'll select all of these items and then we will click group and Shazam. And one more thing that we should probably go ahead and add right now is I want to make a little notch for the motor wires. So what I will do, like I want to make a little detent, if you will. So I can just kind of freehand this shape, make it something like this. Generally, you want to make nice curved, smooth shapes because that will be less stress in critical areas, or it's less likely to break due to stress. So something like this, something so that the motor wires can come out the side or come out over the top, but not actually be above this little cutout right there. So I think that could be very helpful. In fact, we could probably bring that down a little bit more. Sure, let's try that out. So we'll just try that out. We'll select both of those shapes, press the group button, and then shabam, we got ourselves a new shape. And you know, it's not like perfect, but that's what's cool about this is it doesn't really matter, and you do have some, you know, freedom there as far as like making the different shapes. Okay, cool. So now that we have this part, which is basically like the motor mount sort of plate area, which you could actually just like glue, you could glue this straight onto the end of an airplane if you needed to, but we'll make it an actual like freestanding self-supporting motor mount. Now, here we have a couple options. We could either build the the base and the sides upwards, like vertically, or we could actually just take this whole part right here and then rotate it 90 degrees like so, and then build it like, you know, on a flat area, which I think we'll do that because that kind of gives us a better perspective of what this will actually look like. So to make sure that this is not in the middle of the plane like it is right now, I've selected to use the end point, and then I'm going over here to on the vertical, the vertical distance where it shows the vertical distance. I'm going to type in 0, going to boop, bring that back up right up onto the vertical plane. And then we can go back to using the midpoint because that is what we will want to do. Let's see. And what we can also do actually is we can actually take the, if you click on the very center of the ruler, it will actually change which direction the ruler points to in that sense. So this way, we kind of flipped it around, but I want this to be the back. So now we have a ruler on the back side of this, which is nice. So there's different ways you could do this, but anyway, the main point is now we need to add a base to this. So let's go ahead and get our box shape again, and we know that we want the width in this direction to be 30 to match the front, and we want the thickness, you know, it probably doesn't need to be that thick really. Let's just do 3. Let's do 3 also. Oops, not 30. 3. I want 3. And let's make it, we could just drag this. We could make it, let's make it like 60. And then again, I'm going to click so that we're using the endpoint as a reference, and then I'm going to hit 0 on the vertical distance. So don't get too confused by that, but I'm just kind of using that because I feel like it's easier to make it snap to the work plane, or easier than making it snap to the work plane. So we can just kind of, well, for here we can kind of eyeball it if we want to, and since the actual length doesn't really matter, we can just kind of drag the length. I mean, we could even overlap the length. It doesn't really matter. And then now that we have that, we're like, okay, cool. And so we can, you know, we could drag the length of this shape from this side to make it, you know, shorter or longer or whatever. Probably, you know, shorter is probably good because since we're talking about like, you know, weight considerations. Okay, cool. So there is the base of the motor mount. and that is 3mm also. So this will be a nice strong motor mount. Okay, now we need to add the sides. And so for the sides, well, there's a couple ways we could do that. We could, let's try it. We could use a wedge. A wedge would probably work well. So here we have a wedge shape, and we can change the shape. In fact, a wedge will work perfect actually. So we can adjust how tall we want it, and let's actually rotate this 90 degrees. So we have a nice 90-degree angle on one side, and we can just match that up just like that. That looks pretty good. And again, I'm going to go to this little circle with the lines on it near the center point and click it so that we can easily use the bottom edge as a reference, and then type in 0 for the vertical distance, and then get it back on the ground. And again, since this doesn't really matter, we can just leave it on the ground, and then sort of when we bond the two shapes together, or when we group them, it'll be okay that they're sort of overlapping each other. Right, so we can kind of we can just look at that and be like, okay, that looks pretty good. We need to make this a bit taller. You know, we could make it like that tall, something like that. That's about the same. In fact, that is the same. Well, how about that? So yeah, you could do it by eyeball, or you could type in 30 right there. So that should work pretty well. And then as far as the distance, it doesn't even have to go all the way to the back. It could go a little bit less, a little bit more, whatever. Doesn't really matter. The thickness, the actual width of this wall, we could make it 3mm. Not 33. We want to make it 3mm. There we go, 3mm. So pretty darn thick. This might turn out to be actually like a super hefty motor mount, but again, you know, that's the whole thing. Is like you just try it, just do it. Try it, see how it goes. And you see I'm just kind of lining this up on the side here. And you can also use your arrows, actually, they're keyboard arrows, to snap this into place. And it looks like the 0.25mm adjustment is actually too large to get it to actually center up, or to be even with the edge. So I went ahead and adjusted that down to 0.1mm, which, you know, is probably more precision than you really need, certainly for a project like this. But, you know, it's like, why not? Why not? See, I'll tell you what, one thing I tend to do is I enjoy this type of thing. So I really like to tweak things and try different, you know, be like, oh, maybe we could put this here, maybe we could move this over just a little bit. But for these purposes, I'm going to have to just blast through this to make this actually a watchable video. And now we will just duplicate that shape, and we'll take it over to the other side. But what I want to do, since I don't necessarily want to move any of the other positions, I'm just going to use my left arrow, and actually that's going to take forever, but I'm going to change this to 1mm increments. I'm going to use my left arrow and just slide it over, and that should work pretty well. And then I can change it back down, change the snap grid back down to 0.1mm, so that I can get this just however I like it. But you know, it doesn't have to be perfect. It really doesn't. So that looks pretty good. Let's see, how does this look? So you know, just for funsies also, see how this side right here cuts into, or kind of sticks out of this little notch that I created for the motor wires, and I don't like that. So either I could make this side of this support angle, I could make it thinner, or what I can actually do is select this shape and then click ungroup, and it's going to ungroup the last shape that I grouped to it. And now you'll see that this is actually, this oval shape is actually going to cut through the support shape, or this support angle as well. So I don't know, I hope you guys are as excited about this as I am, because I think that's really helpful. And then so now if I group all three of these shapes, let's click group, shabam, look at that. See, now we have a nice cut. You'll notice also it changed the color, actually, because this is now actually one shape, the support angle in the front. Anyway, but I think that's a little cool feature. That particular spot right there, that little angle is probably going to be so small, and it won't even really be, you probably won't notice it much in the printing, but I think it's just kind of a neat thing that you can do. So keep that in mind. You can always ungroup items and then regroup them as needed. Okay, a couple more things that we could do here just to show you. Like, for example, maybe you want to have the ability to put a barbecue skewer through here or something like that. And so you want a hole going through both sides evenly. Well, what you can do, like a hole that matches up. So let's say barbecue skewer, like, I don't know, what is that, 4 millimeters? Probably like 5 millimeters. Let's say 5 millimeters. Or so. And so let's make this cylinder 5 millimeters. And then what we can do is make it longer, like really long. It doesn't matter how long really, as long as it will go through both items. And then we can just rotate it and drag it over here. And then we can drop it down so that it will cut through right there. So you could use this again, like maybe you want to use barbecue skewers, or maybe you want to, I don't know, use it to somehow strap your motor mount down, and then you have two holes that line up perfectly with each other. So that is very cool. You could also make cuts into the bottom here. So like, let's say we get a cylinder. Let's make it have more sides. There we go. So we could also, let's just take this cylinder. We could duplicate this guy, and we could, let's turn it back over like that. Okay. And let's go ahead and make it a little bit smaller, yeah, just to work with. And so we could actually make this a little bit larger as well. I mean, we could even put weird shapes, but let's say these holes are 10 millimeters. Let's make some 10 millimeter holes. So we could also take a cylinder shape right here, and we could add some holes to sort of either lighten the motor mount, or maybe you're going to glue it down and you want some holes for the glue to kind of seep into. So you could kind of do that. Well, it kind of looks like Swiss cheese. Maybe those holes are a little too large. You can do whatever though. I mean, they don't even have to be the same size or the same shape. But you probably want to space them out so that you get some decent, so that it doesn't compromise the structural integrity. Again, this is like not, I'm kind of slapping this together because normally I would not leave something like this where you have an edge, a very sharp angle right there, because it just looks weird. It kind of bothers me. And then printing, you generally don't want to have sharp angles when you print. Of course, that is exactly what we're doing right now. Can we change that? Should I change that? I really want to, but I probably should not. Now, the last step is all of the shapes that we have on here that we're using to build this model. We want to combine everything. So we want to group all of the shapes, and shabam, we get this brand new shape. This is our finished model. This is what it's going to look like. Now, this is not necessarily the orientation that it's going to be printed in, but I think in this case, this will be the orientation. But this right here is our finished model. Kind of looks like a block of Swiss cheese. In fact, yeah, it's like a Swiss cheese motor mount. That's kind of cool. Totally planned that the whole time. Anyway, so this is our finished product. So now we can move this entire model, and everything will stay together. So now what we'll do, let's go ahead and change the name. We'll call this Swiss. We'll call it a Swiss motor mount. So Swiss motor mount. There we go. And what we want to do is we want to export this model. And so we're gonna go over down to the top right hand corner, and we're going to click export. And then we want to export this as, and it gives you the option of everything in the design if you have like multiple items, or the selected shape. In this case, we have just one shape in the design, so that's fine. So we want to do for 3D printing. In this case, we're going to do STL. That's going to be most common. And then it has exported, and it should be in your downloads folder right now. So now the next thing we're going to do is grab it out of the downloads folder and then put it into Cura to actually slice it. All right, now we are in Cura. Congratulations, you have just designed your first model in TinkerCAD. Thanks so much for joining me. We're gonna keep this party going. In the next video, we're gonna jump into Cura. So that video should be showing up on your screen somewhere, or it will be linked in the description of this video. I'll see you over there.